Okay, good. Check, 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 check. Check, 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 check. Okay, good. Check, 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 check. Hello? Check, 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 check. Okay, there we go. All right, how's everybody doing this morning? Great. Okay, I posted this over the weekend on Discord. So going forward, this will work. So this is a lecture search engine. And so the way I have this worked out is that on I usually run the update on Thursdays after the Monday and Wednesday lectures. And so the transcripts get pulled from YouTube and then cleaned up. Then the transcripts come down to the search site. And then they'll be available in two ways. One is that you can just search, and it searches both. It searches the transcript, but then, so there's two things here that gets generated. The transcript, which is, this cleaned up version from YouTube, and then the second one is the timestamps. And so it searches the transcript, but it takes you to the closest, or the relevant timestamp. And then two, I have it compiling a list / outline of all of the timestamps from each lecture. So both of those are available there. You can see the holistic view of like the whole week, or you can search here. And the search site, there's only one search site for all of my classes. So that's also useful, I think, in that if you turn on all of the buttons and search the other stuff, that'll be there as well. If you want to find some information from one, if you're looking for something specific, but things come up from the other classes. So this makes everything much, much more accessible, but it gets updated on Thursdays with the previous 2 days of stuff. So it looks like this. And so if you're just searching for AVC stuff, 185, right? I also have the last semester stuff up there. It's not checked by default. You can check it and look at it, but obviously be aware that, the order, projects, content shifts, but there's, relevant things there. And so here, if we're looking for Blender, it's finding Blender in the transcripts, and then you can go directly to that timestamp on YouTube there. And so the other thing that's here is the holistic look of the week. And so if you go to week 2, it takes you to this page. And so this is, Monday and then Wednesday. And then here, this is a list of all the timestamps. And so there's about like, 30 to 40 timestamps per lecture. And so it's broken down, and it tries to do the automatic outlining of everything that's happening here. So this should be useful, I think, for everybody. I started building this about halfway through last semester, and then students thought it was pretty useful. And so now it's a little bit more fully featured, certainly. And so that's, I think, useful for everybody. And so the video is there, the raw video is there the moment the class ends. But then the video information getting into the database here is a matter of me telling it to run the update on everything. And I usually do that on Thursdays so that I can update all of the stuff, pull down the transcripts, and then work with everything else. So if you're looking for something in materials that we've talked about in 185, and so it's letting you know which class and everything else. At one point I had it pulling screenshots, but that's a little bit too much of a lift for the system. So that's there. The link is on Discord, and then I'll also put the link in all of the resources sections for the upcoming assignments. This is just a GitHub. So just, this I thought was a really, super useful use of AI/LLMs. YouTube does the automatic transcript, and then I use Claude because I like that company. And so Claude pulls down, downloads the transcript. It takes out all of the so that I do, so that that's not showing up in the search results. Then it adds it to the database of everything, and that database is stored on GitHub. So GitHub is, online repository for code, but in this case, it's really just hosting a web page, right? So it hosts the database and the web page, and then both of those, and then once it's all in the search results and it has the timestamps, then it generates the outline for each week. And so that's there. So that should make everything, I think, much more accessible, hopefully, as we're going through. I mean, you have your notes, and then you'll have this sort of global organization of what's happening as we switch between different concepts, and I try to keep things organized as we're lecturing about them. So I think that should work. And the link right now is on Discord, but it'll be in every assignment going forward there. And feel free to check out the other classes. This semester, it's just this one, and this one. 240 is from last semester. So everything is up there. Does it make sense? Cool. Good. Okay, that's all there. And over here, let's get rid of this and come back here. Okay, so everyone start getting some work done over the weekend for this upcoming tomorrow night's thing. Good. Okay, let's look at something I wanted to get to that if you want to include for tomorrow night, you can. But again, the cutoff, like none of the stuff we do today, I expect you to have done tomorrow. Will be a different assignment coming up regardless. But so the thing that the evergreen tree presents is that we have the situation where we have the trunk, and then we have the leaf part of the tree, or needle part of the tree, the green part of the tree, right? So just in the most general way, we want this to be brown, we want this to be green, but we want to join them, or they've already been joined. The fundamental issue here is like, how do I apply a material to part of an object? And the answer to that is selections. So we want to be able to select part of an object. And if we want to be able to select part of an object, that needs to be done in edit mode. So we need to be in edit mode in order to select part of an object and then apply the material to that part of the object, right? So the way I would think about this is the following. Materials. Level 1, pretty easy. Apply the same material to the entire object. This is fairly straight ahead. We've done this already, right? This is when does this work? When I just need the whole object to have the same appearance, right? 2 is apply materials to faces, right? Because you can't apply a material to a point or an edge. A point and the edge don't have any, a single point or a single edge is not visible. It's not, there's no surface there. And so this is level 2, but this would be limited to the geometry of the object, right? So say you have one face that you want to be one appearance, and then another part of the same face to be another appearance. And that's where you'd be into level 3, which we're not going to get to today, where the object needs to have a UV map, which allows the faces to be assigned to individual pixels. Or let's write it the other way. It allows a group of pixels to be assigned to a face, right? And so that's a whole can of worms, which we'll talk about / struggle with / fight for the rest of the semester. And so, this is, hold on to your butts. This is coming up. Let's just talk about this one here because we haven't done this. And so we've got, let's make something new here. We'll delete this, and we'll make a UV sphere for sure. Okay, so I'm in here, and level 1, like we've done before, you make a new material slot or a new material, and you give it some sort of appearance. I can see the color because I'm in render view up here, and right, so that's pretty straight ahead. Even if the material was included some sort of texture or something like that, it would just be applied to the entire geometry here. And I'm going to label this material because once we start doing more advanced things, it's really important to have labels on the materials. And so there we go. And now what if I want part of this to have a stripe on it, right? And so if I need to do anything with the individual faces, I need to go from object mode to edit mode. and tab is our shortcut there. And then our biggest selection here, select Alt-click is going to do loop select. And so this is one of the primary ways to select things. If we Alt-click here, sort of on the edge that's facing this way, it selects a loop of faces going the whole way around the object. Loop select works in edge mode, point mode, or face mode. And if you sort of click on this side, you see that you get kind of a loop here. And so this situation that I can select a loop cleanly here and that I can't really select a loop the whole way around here is a fundamental principle to understand. In general, we want clean loops. These are, if you're reading the literature, these are always referred to as edge loops. Edge loops is not a Blender term. Edge loops is just a modeling term. If you have a choice between an object having clean edge loops and an object not having clean edge loops, we want to have clean edge loops. It's going to help not only in terms of organizing the topology along the face of the object, it's also going to most of the time make applying materials and then also deforming the object much better later on, because the individual we want to have edge loops, right? But Alt-click is not, it's just trying to find a loop out of what is there. And so there is no loop that goes around, because this, if you go from pole to pole on the UV sphere, you go through this point, and then we don't have a loop around the other side. If I were to go to edge mode, I think it would. Nope. Right, and so, yeah, here, let's look at this. We've got our basic topology terms that we'd want to know. Right here, this face has 4 sides, 4 edges. This is a quad. And if your whole object is made of quads, you're going to have more edge loops around the object. I'm not sure if that's mathematically true in absolutely every instance. I don't think it is. But that's going to be the desired topology. So in your notebooks, quads are the best. They deform the best. It leaves you with an even, at a fundamental level, the rendering engine will render triangles, and every quad can be evenly divided into 2 triangles. Next on our topology list here are tris, right? And so that's what we have up here. If you look at this, at the very top of the polar organization of the UV sphere, right? This whole section up here, this is like a circle made of tris, which have obviously 3 sides. Most of the time when we're modeling things, our target is going to be mostly this, and then perhaps there needs to be some tris in order to make it work, okay? And then the other thing to take into account here, if we have more than 4, this is referred to as an n-gon, right? So we don't get quints or whatever it would be after that. Everything beyond 4 is labeled an n-gon, okay? And these we're going to be avoiding here at the beginning and discussing them later on in more detail. So put some stars next to quad in your notebook there. These are, if we can divide our entire outer shell of our object into relatively evenly distributed quads, that's usually a formula for success in terms of deformation, UV unwrapping, all those kind of things. But we can see all, or two of them here. If we were to select the top ones here on these faces, okay, I deleted those top faces and then filled it in. We'll get to those commands later. That's not important. What's important now is that we're able to identify this, right? So what is that? Circle? This is an n-gon, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. The whole way around, whatever we picked for our resolution going around the object. To just discuss this briefly. So the n-gon, what makes the n-gon problematic, right? It's not totally undesirable, but you need to understand why it's problematic. Is because at the end of the day, everything is a trie, right? The trie is the logically least amount of points you can have to define a plane. In fact, any 3 points in space define a plane, period, right? Not just in Blender or this is in reality. 3 points define a plane. And the way that all of the rendering technology is set up is that when it comes down to boiling it down in the GPU before it draws the pixels on the screen, everything gets boiled down into triangles. So one of the issues here that arises is that knowing that this n-gon has to get boiled down into triangles, how would one do that? Well, as soon as you start thinking about this, you're looking at it and you're thinking about these different possibilities, and then as you start to draw triangles here, you realize there would be perhaps many different solutions as to how we would divide this n-gon into triangles. And so that's the issue, is that the computer will do some automatic division of this into triangles, which will affect the shading and affect the topology to some extent, and you have lost control over controlling how that appears on screen. So this is one of the primary issues. There's exceptions to this, but for right now, we'll try to avoid these without having to jump through a ton of hoops. But our 3 basic things to think about: triangles, quads, and n-gons in terms of the underlying topology there. Okay, so now, for instance, if I select here, we can select this, but you see that the loop select stops at this n-gon. This is another, ramification of n-gons. It's like there's no clean direction across this n-gon. And so the algorithm, it's not going to create a loop where there is none. You would need to specify that topology. So for instance, if we were here like this and that and this, And there we go. And so now if I were to, I'm not even sure if this will find it. Let's see. Right, still terminates there, but now that one goes around. Why does that one go around? Because we've defined the actual path in the topology. Right, before, we still have n-gons, right, here on these sides. And so that prevents finding a loop around the object over here. But in this case, because I defined this piece of topology right here, this goes across. So the selection tools that we'll use to assign materials here are directly tied to the topology of the object. Right? The topology, just to be perfectly clear here, is the arrangement of faces on the surface. Right? The surface itself hasn't changed substantially up here on the top, right? It was a flat circle. Before it was a flat circle made up of radial tris. Now it's just a big flat n-gon. And so like the surface is the same, but how we divided up that surface has changed. And so this is an incredibly important term. How we have the faces divided along, across, along, on the surface of the object. And so over here, here we have, if I give it some more subdivision, so it looks a little rounder. There we go. We have two spheres, but they have different topology. We have the icosphere, and then what Blender calls the UV sphere. You'll see this referred to as like a polar arrangement. It looks like a globe. Over here, this is all tris. That's not necessarily terrible. This sphere is more useful in some instances, but this would matter in terms of animating and deforming it. Over here, the topology is perfectly evenly distributed. That's what the triangle, the tri-based topology does for us. But if we come in here and I'm holding down Alt-click, nothing's happening, and a lot of students' initial reaction would be like, oh, my loop select is broken, or loop select isn't working. No, it's working. It's just there's no clean loop here, right? Or the problem is there's many, many ways you could find a loop around this in this triangle-based topology. Whereas over here, if I come back and tab in and select, I'm able to select clean loops. And then the other rules apply here. Shift to add to a selection, Control to remove from a selection, just like selecting pretty much anywhere. And so between the Alt, Shift Alt here allows me to sort of bring in multiple loops if I wanted to make a stripe on this. And so we can have multiple material slots per one object. And if I make another one here and assign a material and make this red for the sake of being able to see it. And there we go. And so now I've got blue and red, and I believe it's going to show me the top one. No, it's not. Okay. This is going to keep blue first. But let's say I wanted part of this to be red. So I have this part. And I can have red selected and assign. And now part of it is red and part of it is blue. Okay. Whereas before, up until just now, we were just assigning one to the entire object, which is obviously, a limited way to be able to control the surface color of any given object. Even if I shade smooth now, you can see that that's there, and you can extend this as well. Like you can come in here and we'll make green. And then we'll tab back into edit mode. We'll make sure green is selected, and we'll make a green stripe right here. And I'll say assign, tab back out. Now, this technique, assign material to face, is limited, or limited by the topology. I can't divide up one face in order to make part of it red and part of it green. You would need to change the topology of it in order to do that, right? And so now that one, I divided up into two triangles there. The tool I used for that is not important right now. Right, and so now it's a separate piece of topology, and so if I grab this and assigned it there, now that could be red, okay? However, I'm just doing that as a demonstration. If you find yourself trying to control the color by changing the topology, do not do that, okay? Soon, I guess next week, we'll open this can of worms. We'll start talking about UV mapping, which allows you to have total control over the texturing of the entire surface. Allows us to assign pixels and then paint onto an object the way you would any sort of physical object at that point. But unfortunately, right, that's obviously what everybody wants to do, right? We've got this form, and then you want to be able to paint on it like you would some sort of figurine or ceramics or sculptures or whatever, right? However, there's a significant step that needs to happen there in order to assign pixels to faces, okay? So when you're using this technique, you should be using it for sort of, large parts of an object, right? Where we, like for our tree, right? So let's apply this to how one would do the tree. So here, let's get our cylinder and give this less. So I'm going to go 16, and then I'll scale this down. Here, I'm going to shade auto smooth so that it still has a corner there. If I go shade smooth on the cylinder, it's trying to shade it so smooth that it kind of obliterates the corner here. The corner, the topology has not changed. The shading has changed, right? So we're going to go auto smooth for now. Gives us this. And then have the same kind of thing here. So make a cone. Again, trying not to have too many radial subdivisions. So I'll just say 16 for now. And scale this down. GZ, move this up. Maybe if I want to change the shape of this a bit, I could tab in and then just grab the bottom face here and scale that up. There we go. And then tab out and Shift D, Z, Shift D, Z, S, S. There we go. This trunk's too thick. S, SZ. There we go. All right, so there's the tree form. Let's come back and look at it this way. These here, same kind of thing. Right click, we're going to say shade auto smooth so we can have that edge there. Okay, and we want these, we want to be able to duplicate these using the array and treat them as a single thing. And so I want to join them. So we'll select these and Control J. Call this tree. And we'll come over here and check our scale. Scale is not at 111, right? So this should be setting off alarm bells in your head. This may seem really pedantic at first, like why does everything need to be 1? It has to do with the way all of the transformations are calculated. And so we need to Control A, apply scale here. And so that doesn't change what it actually looks like, it just makes it 1. Remember, this is a relative number. Absolute position, absolute rotation, relative scale, okay? Notice it's not in meters, which the whole program is by default. Okay, and so now how would we texture this so that we get, brown and green? We can come in here and set that up. I already made a green, so I'll bring that one in. And now I'll make a brown. Let's do that. There we go. Okay, great. And so now, in order to apply these to part of an object, I would need to go to edit mode. Okay, selecting these things. The important thing here to understand that I think gets lost at points or isn't entirely clear is that join does not change the topology. Now that we all have a solid understanding of what topology is, join does not change the topology. So they don't get fused together or melted together. Those are different commands with different issues. These are still completely, the topology is completely unchanged. It's just that this, and this are now just together in one Blender object. That's what happens when we join it. And as such, if you go to wireframe mode, you can see that clearly. So what might, an important thing to notice here is that we do have internal geometry. Right, the tip of the cylinder, runs into the other, or the cone goes into the other cone. For right now, for the most part, this is going to be okay. As long as we don't have a ludicrous amount of stuff in there, especially because we're not UV unwrapping it this week. This isn't that gigantic of an issue. Even when it comes to rendering it, the computer doesn't, the render engine has been optimized to not waste time on what you're not going to see. People far smarter than me have figured all of that out. That's in place now. And so you're not going to waste time rendering. Are you going to waste time modeling? Perhaps, because internal geometry is geometry. And so as you're floating around and looking at things, if you have a ton of geometry, it's going to slow things down. But yeah, so we've joined it, but all of this is still here. This leads me to our next selection shortcut, right? So if I go to faces here and select some faces, I can select through the object now that I am in wireframe mode, right? If I want to select through the object when I'm over here, I can say toggle X-ray, and then I can select through the object in solid mode. But usually I just go back and forth between here and here, keep solid mode solid and wireframe mode see-through. But if I select something and I Control L equals select connected faces. This one's really useful, especially in instances where we've joined stuff, because does joining change the topology? No, right? So they're still connected, and in this case, continuous surfaces. And so Control L is sort of the way we can we can join something but still select objects as long as we have access to the object itself, so as long as we haven't changed the topology in some sort of fundamental way.
I have a lot of trouble with join,
Mm-hmm.
Control J, a lot of trouble with that. I would get a message that would say something like selected, active selection is not part of, active something is not part of the selection. I should have, I'll copy it down somewhere, but I couldn't, I would still see the 4 separate components.
Mm-hmm.
Could not get it to join. Maybe I'm just used to group where you can select each part.
Mm-hmm.
I couldn't, and so I would be trying to apply a material into the whole grouped element. I couldn't get it. So, are you familiar with that message? That tells you that you can't.
I'm not sure which one. I mean, can you try and pull it back up so we can read exactly what it
I don't
says?
think there's so many instances back.
Yeah. So here, right, this is one thing. I'm not going to go. If it's anything that's in parts, keeping it in parts is preferable, right? Like I want to be able to use the array on the entire tree, and so joining it here makes sense. If this was going to be something where each of these things is way more detailed and so on and so forth, I would not join them. Joining, like you're committing to making this a single identity, right? So if you need to animate it separately, if you need to, if you want to be able to continue to adjust their position individually, like you should not join it, right? Because here, we can use this tool, Control L, to do that. If you come in here and select some of the faces and Control L, then press G, now I'm back to essentially selecting, being able to move this by itself. But, that's not a great practice on a regular basis at that point. So joining is really, like I'm going to commit to making these a single thing.
So like I was trying to make a new collection.
Uh-huh.
I don't know, that just wasn't working.
It's just
It's a big
right-click,
thing,
new
parts.
collection.
I wanted to be able to duplicate the thing 3 times.
Uh-huh.
Not an array. The array wasn't going to be the answer.
Yeah, the collection is not the answer either. Collection is just like a drawer you're throwing stuff in. It really says nothing about the location. In fact, the way it does collections, you can kind of have things in multiple drawers at the same time, which seems crazy making, but like, it scales. So, yeah, I think just parenting stuff is probably mostly of what you want.
Okay, yeah.
Okay, so back to here. Let's texture this tree. Okay, so here, I just want the green part of the tree. So I'll grab this, or tab back into edit mode, Control L, grab Shift, and click some other parts. There we go. And then Control L again. That gives me all of the green parts of the tree. And I can come up to green and assign that. Grab this part of the tree, Control L, grab brown, and assign that. And if we look at that over here, there we go, and tab out, and rotate this tree, you can see now I've got green and brown over here. Right, so and you can have as many of these as you want, right, but it's limited by the topology of the object. For things like, well, I want this to fade going down here. I want white on the edges of it. That's all a week or two away. Okay, once we get into UV mapping and everything else, that'll be clear. Okay, but for right now, up until now, we were limited to one material per object. Now you can have multiple materials per object, but it is limited by the topology of said object. I got to redrag it over there. Okay. Okay, good. The other thing we want to do here is think about the anchor point. Once you join anything, you want to be able to, you want to make a conscious decision about where the anchor point is. And so, having this anchor point here in the middle of my tree is probably not a great idea. For the most part, right, when you're thinking about the origin is going to be the Blender word, but I'll go back and forth between origin or anchor point. For the most part, the center bottom makes the most sense. That makes it possible when you zero out the object, it'll sit on the ground. So here, in this case, I grab this. Remember, I'm clicked N, went to Tool, went to Origins, and now if I press G, I'm not manipulating the object, I'm manipulating the anchor point, okay? So this is also a gotcha. People get a bunch at the beginning, is that they go into Origin mode, and then they're like, oh, I can't move any of my objects. It's because you're stuck, this is a toggle, right? So any of these kind of toggle switches are danger zones for turning it on and then not knowing what state that you're currently in. And so then turning this off. And so now if I Alt-G this tree, it goes, to the center of the world. And if I had a plane, if I only had a plane, see what I did there? Little Wizard of Oz, or Wicked joke, I guess, at this point. I mean, I haven't seen the second one yet, so. I assume the Tin Man shows up at some point later. Yes? Okay, it does. All right. Now, putting it not directly at the bottom here is a little bit of a strategic decision for me. Does this mean I'll have essentially, internal geometry, geometry that doesn't get rendered? Yes. But it also makes it a little bit more flexible that if my ground is a little bit up and down, right, and this sticks through the ground and it's putting the anchor point there, it's always going to look like it's flush with the ground because it'll just be a little bit through the ground there, right? So having this little bit of internal geometry, this is like what we did before, right? So if I scale up this plane to make it something, so just S, and there we go. And then Control A scale, just to make sure I'm keeping that where it is. Tab in, and then this is one face right now. Like this, besides a triangle, this would be the simplest. We have one one quad here, and so this is something I can bring to your attention, right? When we have one face, this is not going to bend. And so when we take this point and start moving this around, you'll see that the lighting gets weird. That's how a lot of people will describe it at first. Oh, the lighting is weird. What's really weird here is the shading, sort of how the computer is figuring out the surface of this individual quad right here. And the thing I would write down in my notes is that we have made this quad non-planar. Non-planar. So any 3 points, any trie is always planar. You can't have 3 points in space that are not planar. They always define a perfectly flat plane. as soon as we get to 4 points, it can be either planar or the opposite, non-planar. Meaning that we cannot pass a perfectly flat plane through the quad if it is non-planar. So quads can be planar or non-planar. Tris are always planar. Again, this is not a Blender limitation, or in the future they'll figure out a way to make non-planar tris. It's not geometrically possible given our current understanding of geometry. And you can see it now as you're looking at this, right? This is why, in order to make some sort of curved surface, we need more subdivisions. Why do we need more subdivisions? Because a single face cannot be bent, okay? It can be made non-planar, but it's not a smooth curve, right? I used to say it can't be bent. Maybe it can't be curved is perhaps a better. Both of those are accurate here. We can't smoothly curve it here. Most people wouldn't describe what we have here as some sort of like smooth curve, right? This is just a non-planar quad. If I made a new quad here, and I tried to match these up, right? This one is perfectly flat. This one is planar. This one is non-planar, right? How did I make it non-planar? I grabbed one point and just sort of moved it around. And so it's impossible to make this one line up with the other one, right? I can get it to line up with like maybe this part, or maybe make it line up with this part, but I can't make it line up with both if I keep this one completely planar. This is not, I'm not trying to teach you a value judgment to have about your geometry, okay? When you model things, you're going to have planar and non-planar quads, right? It's the degree to which they are planar and non-planar that ends up being an issue in some cases. But you need to be able to understand the concept of what something being planar versus something being non-planar means. And something being non-planar is it's binary in the sense that it's either planar or not, but it does you can be slightly off, right? You can be very close to being planar, or you can be way off, right? Something like this is most likely a problem in most instances. It's going to create a problem for rendering. It's going to create a problem for UV unwrapping. Something like this, where this is just slightly non-planar, this is not going to be a problem, and it's frankly unavoidable. If we want to maintain quad topology, you're going to have slightly non-planar quads, and that's fine. It's just the reality of making things mostly quads at that point. So, questions about the idea of something being planar versus not non-planar. Again, not like everything has to be planar. You just need to be able to understand that concept, and you'll see as we keep going here how this plays out in a variety of different contexts. And so understanding that fundamental thing helps make a lot of decisions here. Okay, so I want to be able to curve this surface to make it look like ground, which I did really, really quickly before, by combining two things. But let's look at those two things in a little bit more detail here. is that many of, we've talked about our atomic stuff, right? Our edges, points, and faces. Then we went up to objects, which are essentially our primitives, our spheres, our cubes, our planes, cones, etc., right? And then we went up to, objects with modifiers on them, and the modifiers are doing something to the primitives. And we're sort of going up this level of proceduralism. It's important to realize that many of the modifiers are also tools. So what's the difference between a modifier and a tool? Let me turn off the tree and we'll investigate. I'll duplicate this plane. Or just make another plane and scale it up. There we go. And I'll move it over a little bit. I'm going to make a sunlight just to see what we're doing. Okay. Good. Okay, so we've got 2 planes roughly the same size. Just to make an example here. We're going to use a tool over here. And, some of the tools are very simple. They're essentially just end up being, just a command. Some of them have more parameters. And then over here, we'll use the modifier, right? And so here, how would we subdivide this using a tool? Most of the tools are going to operate in edit mode. And so you're performing some sort of operation on the geometry. And this is destructive, meaning that the only way to undo it is just Control Z. You're committing to that operation. And so if I tab into edit mode, go to face, and select the face here, right click and say subdivide. There we go. I have destructively, meaning that I've, permanently, for as much as anything is permanent in the computer, I can, unless things go horribly wrong, I can Control Z back to not being subdivided. But I've made that permanent change to the geometry. Now I can right click and say subdivide again. And we discussed this before, and it's really important to memorize this math. Max, when I subdivide one face, how many faces do I end up with? Max, you know this one? When I subdivide one face, how many faces do I get?
I don't know.
Kevin? 4. Exactly, right? When we subdivide, we always do it this way and this way. This is another reason we want to be mostly quads, because this math works out evenly. And because when we get to a triangle, right, there's really no answer, and there's no clear answer if you want to draw some other line here, right? Again, now we have, it's not clear what's going to happen here. And most of the time, the computer doesn't do anything in those instances unless you tell it to, right? And so we've subdivided here using the subdivide command. Now, over here on this one, I'm going to end up with the same geometry, but I'm going to use a modifier. And so over here, I'll come in and, not on the material, I'll come over to the modifiers, and we'll look for the subdivision surface. And if we put that on here, I'm going to switch from Catmull Clark to simple for right now. Just, take my word for it. And now, I think I did it twice. If I were to go over here, it looks different, but they're both subdivided. Why is this? The modifier is not going to show you the subdivisions. They're kind of like instances in that they're being calculated live here, in that now, they're both subdivided equally, but one's being done with a modifier, the other one is being done with the tool. The thing is here with the modifier, later I can do stuff to this geometry and then decide to turn down the amount of subdivisions, right? So for instance here, let's look at it with perhaps 2 spheres. So I'll make the UV sphere, and I'll make this less 16. There we go. And zoom in on this. Okay. And then I'll Shift D this over here. Okay. And come out. All right. And over here, tab in, right click, subdivide, right click, subdivide. There we go. I've subdivided this sphere. Come over here, add the subdivision surface, and 1, 2 gives me at the same level, but now this one is adjustable. So most of these things can happen as a tool, destructively, or as a modifier. And that means that you can adjust the value later, or at any time, really, as long as it's a modifier. So why not always use modifiers? This seems more useful, right? Rather than tools, which I'm committing to it. It's because this is adjustable, and it creates this chain of, what are we doing here? Chain of manipulation, or let's call it generation, I guess. And you're sort of keeping track of the chain the whole way. And if you're going to, this breaks down at some point. You can't continually build the chain out indefinitely and have this infinitely adjustable amount of work here. At some point, you want to commit to being able to change the actual shape, and then where you can, use the modifier as needed. Okay, so for instance here, this is what I did very quickly with the plane, and this is the reason I did it, is that I had this plane that's going to be the ground, and I wanted to make it uneven, right? So that doesn't look just like a flat plane. And so I came in here and I subdivided, and I probably did that, 3 times, like so. And so this gives me enough geometry now to be able to make changes to the topology of the object, but not so much geometry that it becomes not only sort of computationally problematic, but also selection problematic, right? So the other thing to keep in mind in terms of more geometry becomes harder to edit, right? If I do this, now I'm in a situation where I can grab a very specific part of it, but I have this, the edge is going to look terrible, and then also now doing any sort of other editing, if I go to Alt Select to loop select things, right? This is not a super useful loop selection. This all becomes very, very, very problematic here, having geometry that's this dense. Okay, so especially now, everybody, this should set off alarm bells for you. If you've manipulated some things and you go into edit mode and it looks like this very, very, very dense arrangement of faces, this is probably, it's definitely not efficient. It's going to take it more work to do, and it's a real pain in the butt to edit, right, in terms of being able to control this. And so how do I decide how much topology? Just enough, right? For whatever it is that you're making, you want to you have just enough to properly represent the surface and define all of the detail that you want in the surface. If you subdivide too much, if you come up with too much topology, you know, especially when you really crank it up, you can run into all sorts of problems and difficulties in terms of editing said topology later on. Okay, but this example is definitely too much here. Okay, the difference between, you know, this and this, that's very minimal. Okay, like both of those would be probably reasonable answers here. And so this gives me something that I can edit, right? I can move these points around very clearly. I can clearly understand the shape of this object, but it's not smooth enough, right? I want this to not look like triangulated ground. I want it to look like hilly, smooth ground. And so this is a very clear instance of where we're using a tool for our, you know, base or, you know, sort of gross, meaning big in this instance, manipulation of the topology. And then we'll use the modifier to do the smoothing, right? The subdivision surface modifier smooths things out. However, there is a separate modifier called the smoothing modifier that's different, does a different thing. We're not going to talk about it right now. But the subdivision surface one is going to smooth it out, right? So I've got this here. Now I add the sub-D. There we go. And if I come out of edit mode and turn off this light to get a little bit more, come over here. There we go. All right. And so now if I grab this light and move it around, we are smoothed out, but we can still see the individual faces. Okay. Is the solution here to turn up the subdivision even more? No. It's to change the shading on the object. So this is a difficult concept here at the beginning, right? And so if I go shade smooth, it does smooth out the shading. Shading is how the existing geo is rendered. Sub-D changes the geo. So we're using sub-D to be able to manipulate the actual shape of the object. The shading decision here in terms of smooth shading versus flat shading, I mean, most of the time we're in a variant of smooth shading, unless we're making something that's very specific, sort of stylistic, low poly kind of look, like we're not doing this. And the only reason that's a retro look is because the technology to do smooth shading at a scale was not always available. And so older things don't look smoothly shaded. Much older things, right? Like older, in this case now, older than most of you in class. But yeah, this is our difference. Our smooth shading sort of smooths this out, whereas the subdivision, this little computer here, this turns individual modifiers on and off. So if I turn that off, right? See how this looks smooth here still? That's because we're in smooth shading. But this part popped up, right? And so this is the artistic manifestation, is that the shading does not change the silhouette of close-ish, I think. H-O? Okay. All right. No one knows. Who could know? It's unknowable how the one would spell that word. It's French, right? So, yeah, the important thing here is the shading does not change the silhouette, right? And so if we, If we turn this on, you'll see that that gets smoothed out now. Smoothed out to whatever subdivision level we have this in, right? So if I were to make this more of an extreme example, if I grab this and GZ and move this up, like so, with this subdivision on, as I turn this up, you see it smooths that more and more, the silhouette of it, versus the shading. So the smooth shading is kind of what's happening across a single face, whereas the subdivision is creating more faces. So if that's the case, why not just crank this thing all the time so that we get very, very smooth representations? Because that's not efficient, right? It's making, every time I turn this number up by 1, what do I do to all of the faces on the object? What's the mathematical, how do I solve that? I have X number of faces. I turn up the subdivision level by 1. Now how many faces do I have? 4x. 4x, right? And so this is another danger zone for new users, is that, one, they either grab this and just start cranking it left and right with their mouse, and that's a formula for disaster, especially if it's a larger object with more faces, because you're like, oh, I'm just cranking, it just went from 1 to 5, right? But really, the math you just did was, multiplying, what was that, 2 the x of whatever this was as you go by each time, right? So when you're doing this on the subdivision surface modifier, just click once, up and down. Don't grab this and crank it left and right. We should really make it a different interface element there. And so how smooth does this need to be? Well, that's the decision you need to make and answer as an artist, right? What angle am I going to see this at? Am I going to see it at this angle? Well, then maybe one more gives me a hill that once I shade smooth, looks smooth enough, right? Especially if there's going to be a bunch of trees on it and everything else. Like that looks pretty good. Whereas like this level of subdivision looks pretty janky, right? And so how much topology do I need? Just enough. So the just enough answer is not only a matter of the topology, it's also a matter of the viewing angle, right? And so if we're really far away here from this thing, now I could dial it down to like there, and that's enough, right? So you need more detail when you're closer to something, when you're viewing it closer. So you can think of that either way. If we're moving the camera closer, you need more detail. If the object gets bigger, you need more detail within the same view, however you want to think of that, right? What matters at the end of the day is the size in the frame, regardless of the scale of the frame, the scale of the frame as it compares to the world, just how much of the screen is it taking up, right? And that's the main thing that's going to make a decision here. This is, for those of you, video gaming, this is referred to as LODs. LOD is called level of detail. And so this is a system that, because let's say that this mountain is in a video game, right? And our character starts off far away and we just see this mountain in the distance, but later in the game we walk up to that mountain and we climb it, right? Well, how many subdivisions do I need? Well, if it's in the distance, like that's fine. But now when my character walks up to it, it's like, ugh, that doesn't look good. And so level of details essentially program in multiple levels of subdivision. And so when your character gets close to the mountain, it subs in a higher LOD, right? So like the same object has multiple levels of detail And so that when you're far away from it, you get this one, which will render really, really, really quick. And then when you get closer, you get this one, which looks much better when you get closer.
Are you making two different objects? Or is it-
No, like we're not, like I'm just talking about this. We're not doing this, right? In general, no. You just make the high quality one, and then behind the scenes, the computer makes cuts it and makes lower poly versions, and then it handles swapping those in and out at various distances, right? So most of these systems now are fairly hands-off. You just feed it the good-looking one, and then it handles all the other stuff. The good news is that this is the future / now. If this is everything employed this system, then you could just make super detailed versions and then let the computer sort it out, right? Like based on how close you're rendering it for anything. And this is happening, right? So those of you who know Unreal Engine stuff, there's a whole system called Nanite that essentially does this. This is, when I teach this class in 5 years, probably this whole section about being aware of efficiency, barring some terrible apocalypse, the computing system will be fast enough that you'll be able to dynamically generate these LODs on the fly, all behind the scenes. So you don't have to, this is not a thing that people working at the art level need to even consider at that point. And we're kind of there already. I mean, there's systems that do it, but like early days in terms of there's still issues there. But it's essentially doing, a version of this, right? As you're further away, it turns that number down, and when you get closer, it turns that number up, like so. Okay, so let's put our tree in there. And so here's our tree. Okay, I want to keep our plane this scale, and so I want the tree, tree is too big, I want it to be small, and so I'm going to scale it down. Then I'm going to Control A, scale again, and so that's the size, that is my, we'll call it the canonical tree, right? That's how the standard tree size relative to the ground. And so in order to set the canonical tree, you need to apply scale, which means that scale equals 1, 1, 1. Okay, the apply scale command, if right now you're just taking my word for it and you're just like, Casey said apply scale, so I'm going to apply scale. That's good. But the reason you're applying scale is to get to this number, so that it's 1, 1, 1. And so now on the plane, I can add the scatter on surface. And the scatter on surface needs to scatter the tree. There we go. And now we can take care of some things. It blew it up a bunch. Why did it blow it up a bunch? Because I haven't applied scale on my plane. This is really important, right? So I come back. Let's go to the plane and select it. And Control A, scale. Everybody see what happened there? This is really, this is the key to far less pain getting started with Blender, okay? The tree, I did exactly what I said I did. I set it to 1, 1, 1 at the size I wanted. And the size I wanted was this size, right? Okay, and so I took my plane here, I put the scatter modifier on it, right? And then I told it to scatter the tree, and then it blew up my tree. What the hell? I just spent all that time directly telling it what the canonical tree size was, right? This issue is exactly why we apply scale. I just haven't applied it to the plane, right? And because I haven't applied it to the plane, the tree gets multiplied by whatever the scale is for the plane. And if we look at the plane scale by coming over here and looking at this, 8.239, right? You see this, and this should send shivers down your spine at this point. You're like, ugh, oh, okay, that's the problem. And so watch what happens. As soon as I apply scale on the plane, Control A, scale, boom, everything operates as expected. The tree maintains the canonical tree size that I went through the trouble of setting, and so things are working correctly. I don't need to go back to the transform here to change just the default scale of the tree. If I want to add variation to the scale of the tree, I can do that to sort of get some, or no, that's just the general one. Here's for randomize. So axes, there we go. So we can make some tall ones and short ones. And so especially when you're using modifiers, apply scale becomes super important because the modifiers essentially use the scale to process whatever it is you ask them to do at that point. Okay, the other thing to check out here is a lot of times when we can provide an object to as an input here, many times in Blender you can provide an object or you can tell it to use a collection. So if I were to turn this stuff off and come back and look at this tree, okay, here's a tree, and then I want to make a tree that's only 2 things tall and another tree that's like 4 things tall. And so I'm going to Shift D. I'm not going to make an instance because I need to actually edit this thing. And so here we are. This is going to be tree short. And so here I'm going to tab into edit mode, select the top here. Let's go into face, grab this, Control L to make sure I get all of those faces, and then just delete them. And there's my short tree, right? And then let's make a different one. Tab out, go back to the original, and then again, Shift D, and this one is going to be tall tree. And in tall tree, I will tab in. And again, I'm going to use that Control L, but I'm going to Control L, the top one, then I'm going to Shift D, Z, that geometry. So the Z just locks it to the Z axis going up, and then scale that down. And so now I have a tree that's 4 things tall, I have a tree that's 3 things tall, and a tree that's 2 things tall. And then I'll tab out. And so I've got those 3 trees there. I want to put these trees in a collection so that Blender can, address these trees as a whole. So I'll right click and say new collection, and we'll call this trees, and then we'll just drag these trees. Can I do all 3 of them at the same time? I think I can. Yeah. So the trees are in the tree collection. And now, coming back to my plane, Turn all that stuff back on. Down here, I don't want to just instance that tree, or I want to switch to collection rather. And now I should be able to grab the trees collection and boom, there we go. Now it randomly selects from the entire collection of trees there. The modifier is super useful here in that it's doing this scattering live. And so now if I come in and I change the underlying geometry of the plane, everything updates. Right, so now it's not a hill, it's a, valley or whatever. Or yeah, a valley. So like this and GZ, bring these down.
What are you using to do? The modifier on the
I'm not doing anything to the modifier. The modifier is doing it all on its own. All I'm doing is changing the geometry of the plane. I'm just grabbing points.
okay.
Yeah, just grabbing points on the plane. Again, this is easy because I don't have that many points on the plane. I just I need to turn that off. There we go. Right, I have a manageable. How many points do I have? Just enough points, right, in order to manipulate the plane. Yes, Mark.
I'm noticing that when you choose the collection of trees, it's putting them in the row that you submitted them. So I'm noticing,
Yeah.
like, if there's like a placement towards the edge, because it's in a row, one of the trees is just off the edge and not connected at all.
Let me see. Mm-mm. Mm.
You changed the setting and now it's working.
Yeah, so whether something goes off the edge there, I mean, these are the, original trees, right? And so if these are, just make them invisible, now they're not, there's no floating trees in the middle there. But,
Was it because you had pick instance selected? Was like underneath instancing, yeah, on the left there? No, yeah, there. Yeah, that looks like it chooses all three trees at the same time. So you can see like a tree
Yeah.
off the edge.
yeah. So
Might
we
be
want
an
that,
important thing to select.
yeah, we want that one on.
Differentiate them.
So if I go back to a mount and just say 1 and turn that off, yeah, it gives me the 3 trees as they are. Pick instance allows us to, in almost every instance, in almost every time I would be working, we would want to have that checked in this case, so that it randomly picks from all of the trees. Thank you very much, Mark. Good eye.
Yeah, you're welcome. It was just something I noticed, and I was like, I was wondering how I could fix something like that.
Yeah. So when you're using the scatter on surface, or anything that does a bunch of multiples like this, being able to dial it down to just 1, so you can be like, all right, what is it doing once? Then it becomes like inspectable in terms of like, am I doing what I think I'm doing? And then you can leverage the power of generative stuff in order to create more trees there. Okay. Let's save this one. Let me turn these off for a second. Okay, a little bit more on the individual geometry here. So we've got the UV sphere. We need to discuss normals. What are normals? You think of this as a direction the face is facing. Technically, the normal angle is perpendicular to the face. This idea of drawing this perpendicular line to the face, like when you see it here, like conceptually on one face, it's very simple. But this is really important for a variety of reasons. One, it's really integral to all the math that gets done for calculating how light goes across the surface of the object. And so this ends up being a really critical thing. And it also ends up being important here in terms of shading and everything else. But when you think about the faces, what a lot of people, and myself included, is that you see these thin faces and you tend to think of the faces as like paper, because we're only making the outer shell of the object. As we've discussed before, we're not worried about defining the internal density or the internal structures because we'll never see them, right? And so you think of it as like, okay, it's like this paper shell of it. And this is not a complete metaphor in that the paper only has one side. And so this is where the paper metaphor breaks down, because this doesn't make any sense in the real world. You can't have one-sided paper, right? Like it by definition has two sides. So first of all, here, if I were to zoom in on this, so the normal angle on any given face is going to be this line that comes out perpendicular to the face, like this, right? Just sort of these like spikes that come out from the face of the object, from the center, not the face of the object, from a singular face. This is another reason why that planar concept is really important. Because if the face is not planar, drawing this perpendicular line, a line that's truly perpendicular, meaning 90 degrees on this level, at that angle, from the face becomes impossible, right? It's not, what is perpendicular? There's infinite answers to that question, because it's no longer a flat surface. And so having things be planar makes the calculation of the normal very, very, very clean. And this, this spike, you can think of it as only going in one direction. There's not another spike that goes inside the object. And so this normal issue is two things. It's which direction is the face facing, and then separately, what is the normal angle? Right? We want it to be this 90 degrees from the surface. So if I come over, let's go to solid view for a second here, and then in order to see this, we want to be geometry. If we turn that on, we can see the geometry in solid mode, and then face orientation. Let's turn that on. Now, watch what happens. I'm outside the object, and I zoom inside the object, and it's all red. So this is the thing to really key in on here, is that red equals the backside of the face. Different rendering environments treat the backside differently. Sometimes it'll get rendered, meaning that it'll function much more like paper, where we flip it over and we see both sides. Other times, it will be culled, meaning it gets removed from the rendering, and so it essentially becomes invisible. You see through. There you go. So this one right here, face orientation. For right now at the beginning, I would say always checked. This is going to make that backside red. So you're very, 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 very clear on, you know, what is happening here. So this really becomes an issue when we start moving points and edges and stuff around. For instance, if I grab this face here and then I press G and sort of do this with it, right? And so I sort of pulled the object through itself. And if I don't have back face or face orientation on here, the, you know, it may look like this is a legitimate shape to make. But there's a bunch of problems here. The main one is that this is actually the, you know, you've essentially torn it inside out. And so there. This having the face orientation on really shows you what's happening with the actual geometry. Let's grab this one and I'm going to move it back here like so. And now, let me turn that off just for the sake of demonstration. And then come over here, which is in a slightly different place, and turn on back face culling. And so now, if I were to go inside, or let's just actually grab some faces like so. And then I'm going to face. Where is it? Normals, flip. There we go. Tab. And turn this off for the sake of seeing this here. There we go. And so this is, for instance, this is a major problem for AVC 200, where we're making video games, we're sending things over to Unity, and by default, Unity and most game engines are going to call the back face of something. And so it looks like there's a hole in this object. But if I come over here to viewport shading and wireframe it, you get this. And if I just showed you this, you're like, okay, well that looks, I mean, this one face is messed up down here, but the rest of it looks continuous. But if I come back here like this, we see this and there's a hole in the object. It's because these have a flipped normal. We've essentially flipped the face in the topology of the object. And so now if I were to come into the sphere, if I like zoom into it and turn around, although with the lighting I might not be able to see it, we'll see. There we go. That's what it looks like from inside, right? We're seeing the face there. It's not a hole in the object, It's just that these have flipped normals. It makes it very easy to see when you have this enabled and you have this off. So don't turn on back face calling. Having the face orientation on is much more useful. And in general, your notes, you can shorthand all of this to this. Turn on face orientation, and red equals bad. Okay? In general, being able to see the red faces, unless you know exactly what you're doing, is generally going to be an issue. How do you fix this? You need to align the normals and essentially have all of the faces face out. And this is in the mesh menu, and then there should be an align normals command. So if I come back in here, tab, edit mode, and grab everything, right? So I just pressed A to select all of the faces. Mesh, normals, and here, yeah, recalculate outside. This kind of looks at all of them, and it figures like, okay, most of them are in this direction, those don't match, and so it changes them. And so recalculate outside, boom, fixes it. You could also fix it directly. You know these are wrong, so you can shift click all of these, go to mesh, normals, and flip. Now those are facing the correct direction. So this will come up again and again, but it's related to what we've been talking about in that we have this view. I thought we could visualize the normals over here, backface, depth of field. No. Over here. I will leave it at that for now. So this goes back to our atomic level stuff. We have our points, edges, faces, and then on the faces, we have our face normal angle, right? Which direction is the face actually pointed in this direction? It's going to be this 90 degrees, which is perpendicular to the surface. And as soon as your plane or your face becomes non-planar, this becomes not as easy to calculate. Everybody still there, live online? Everybody all good? Okay. Okay, let's manipulate a little bit of the geometry here. So let's look at some tools here. Not every tool has a modifier equivalent, like I was talking about before. The ones that it makes sense to do that do. But we've got some shapes that we can do with the primitives, but obviously you want to be able to move beyond just working with the fundamental primitives, right? We want to be able to manipulate the shape of the object in a much more nuanced and high fidelity way. And so there's a lot of tools here for doing this. They're all going to be essentially destructive. We sort of perform them as commands in order to move things around or change things or add geometry. So some ones we'll look at here at the beginning is that we will extrude a face. This allows us to pull it out, and it actually makes more geometry, right? So it's changing the fundamental topology of the thing. We'll inset a face. And then we can use the, in order to have more geometry to manipulate things, we often want to cut them. And so we have our loop cut tool and then the knife tool. And so extrude and inset are kind of simpler things, whereas loop cut and the knife tool especially is like a more fully featured multiple options kind of thing. So between these four, this isn't everything, but you can get a lot of work done with these four things. So let's look at these. Okay, extruding first. These are all tools, right? In your notes. If you're going to use a tool on the topology, which mode do you need to be in? Exactly. Very good. In edit mode, right? Because edit mode is where you access the topology of the object. If you're going to use modifiers, you need to be in object mode, right? Because they work on the entire object. In fact, a lot of times when you go into edit mode, it stops showing you what the modifier is doing so that you can see the topology. So let's come into edit mode here and then select a face. And there's some confusion about this at first. First of all, I've selected one, and check out the gizmo here. Now that I have the gizmo turned on, it is oriented to the global up and down. And so that is often not what we want, right? This can go straight up and down according to the global coordinates. We put it to local. We get the same thing because this is still just in the center of the world. If we switch it to normal now, watch what happens. Now that you know what normal means, boom. Now the gizmo has reoriented itself according to the normal angle. You see that the Z is directly out. It's the normal angle for that face. And so one thing that students get confused with here at the beginning is they'll select a face here and then they'll do this, sort of grab it and do this. This is moving. All you did was move the existing topology. You did not extrude. Okay? In order to extrude, I'll select a face here, then I'll press E to get the extrude tool. And I'm just press E, and then you move the mouse. That's controlling how much I extrude. And then I click to sort of stop the extrusion. And so this is extruding, and this is moving. Check out what extruding did. Extruding made more topology. This face, and the two on the other side were not there before. This one, there is no new topology. I just moved the existing points. And so if I grab one and move it out, you can see I can, now I can move something in like that, right? If I just press E and moving it in or out like so. Then I could grab any other face and extrude that. And so now you're starting to see how this opens up the world of like making literally any shape, right? Because now we can make more, not just the extrude tool in combination with the other tools, but now we are manipulating the fundamental topology of the shape, right? We're not just grabbing a primitive, we're grabbing a primitive as a starting point, then manipulating said shape there. And so if I grab all of these up here at the top, right, like so, like that, I could extrude all of these at the same time. Got to make sure that I only have these selected here, kind of like so. E, and that brings that up. Now I could extrude this from here. Let's save this again. Okay, extruding. The issue comes, right? Let's get multiple things selected and then extrude them. And I get this. So look at what's happening here. So if I just press E once, it's extruding it along the center normal there of what's going on. A lot of times, what we want to have is like, I want to create a lot of different, if I grab a bunch of these unconnected ones and press E, there we go. See what happened there? See how they all extruded out in the same direction? This is often not what you want in many instances. I mean, it's a legitimate shape. It's just not artistically what people are expecting. They expect it to sort of spike out in each individual normal direction, right? And in Blender, that's actually like a separate subtool. And so this is the actual thing you click on if you don't want to press E to get the extrude tool, right? And so if I press that and I press the extrude region, it gives me this yellow handle. This yellow handle, when I'm using tools, essentially is the thing that you click on to use the tool. And so if you click here and start dragging, it brings it out. Anytime you have a button like this in Blender that has the little triangle at the bottom, if you click and hold, it gives you other options. Am I going to be able to zoom in on this? Yeah. And so if we wanted everything to go out relative to the face, this one is super useful here. Extrude along normals. So watch what happens now. If I select that, and then I select multiple faces, and then I click and drag the yellow, now it is doing what I imagine more people expect as the default behavior, right? It's extruding out along normal, right? Sometimes this is what you're going for, where everything extrudes in the same direction. Sometimes you want everything being extruded along the normals. That's this tool, and so that comes out like this. So this makes way more sense now that you know what a normal is and what the normal angle is. So that extrude along normals should be much more helpful here. Most of the time, I'm just using regular extrude or extrude along normals. I'm not doing a bunch of the other ones. So now combining this fundamental manipulation with perhaps smoothing, right? So here's the subdivision surface. I right click and I say, or if I select the object and shade smooth, right? And maybe I smooth a couple times. Right now, you can start to see how these things work together here, right? This allows me to create these sort of smooth surfaces with the subdivision surface, but then manipulate the geometry itself in this much more easy to handle surface. We're going to turn that off for now, just to keep an eye on the regular geometry here. But extruding, right? And we can go in either direction. Next tool that's pretty useful here, let's go to a cube. Let me turn off this thing for a second. I'm going to tab into edit mode, select this, and I, for inset, is going to do this. It insets the face like so. And so now, we can use inset and extrude to create a whole bunch of very desirable shapes, right? So I'm just clicking, I'm pressing I, then I click, then I select the face, then I press E, and then over here, I, E, I, E, I, E. We could come in here and select I. Then, let's say we don't want it to be a perfect inset. We want to scale this. And so now, if I press S, Z, I can, or let's go S, Y. You can come in and grab the edges and manipulate them. Then I could come in and move, extrude this one part. So this is just there now. And now we extrude this. I want this to be a smaller window here. I can come in and grab these edges. When I make these changes to the edges, I think it's useful to be in orthographic mode. And come back to face and E, bring that in. I, E, right. And in starting with a cube like this and just using this series of insets and extrudes, keeps everything as quads, which is great because that's what we talked about earlier, that being the best option. So it's important to realize that a quad is not a square, right? It's just four edges. So over here, something that looks trapezoidal like this, not a square, but still a quad, right? So and in this case, a planar quad, right? Everything is perfectly aligned to that plane over there. So we're extruding, insetting, extruding. Then a similar sort of situation, if we wanted it to look very geometric, if we wanted to smooth things out, the subdivision surface subdivides there, depending on how smooth we'd want this to look. So this general, let's just leave it at that for now. Okay, so that was extruding and insetting on those two things. Let's do one other one here. In loop cutting, right? So let's say I want, one way to make a window in the top of this or an indent would be to select the top face, inset, and then extrude in, kind of do this, right? But let's say I want a thinner sort of window over here. And I could manipulate the topology before actually doing the extrude. And so I'm going to, this is a super important shortcut. Loop cut is Control R. But just like loop select only works when there is a clean edge loop. Just like loop select, right? Remember I had loop select earlier and it selected around the sphere in one direction but not in the polar direction because there was not a continuous edge loop around the entire thing. And so this is where modeling can become frustratingly, what's the word I'm looking for? You can paint yourself into a corner often here. If you make some poor decisions at the beginning and create a bunch of geometry where there's not clean edge loops, it makes the further manipulation of it later on more difficult, because the tools for clean selection of edge loops don't work because of some misalignment of the topology at the beginning of the process. Here with this cube, we should be able to do this fairly easily. So I press Control R, and I get this yellow line. And if I just click, it'll cut, or it won't cut. It will start sliding. So this lets me reposition it. And then if I click again, now I have made the cut. And so I've made more geometry. Now I have more geometry with which I could use to extrude just that part, right? If I wanted to make a chair, right, like that. And so down here, I could come in and select this, and maybe, yeah, GZ, move these up. There we go. And now I want to create the legs of the chair over here. So I'll Control R, click, move this over here, and click again. And so that gives me some of what I need. I want to be able to extrude a thin leg out of here. And so I'll Control R on this direction, right? So when you Control R, then you're in selecting which loop do you want to cut. And so in this case here, and there. Now Control R again, click, and there. There we go. Now I have the topology I need to extrude these at the same time. And so now I can press E and make the legs to my chair. Right, so I manipulated the geometry, to make a back for the chair here and here, E. This is really simple, but you get the idea. Inset, E, there you go. So when students see this kind of like super simple chair shape at the beginning, a lot of the initial reaction is like, oh, these are separate cube objects that I've just, Control A cube or Shift A cube in order to put all these objects together and then join them. No. What happened here is we manipulated the fundamental topology of the object in order to make the shapes that we want. Like, let's say there's a ridge that runs along the outside of the chair. Control R here, move this over, Control R there. Alt click on the face. Loop select selects the loop that goes around the entire object. And so now we could extrude this, or let's do it extrude along normals. There we go. And so that creates this edge that goes around the entire object, like so. Now, this, I'm cherry picking the things I could do here that are going to work, right? Because I've been pretty strict about doing just extruding and insetting. It's maintained quad topology. And when you maintain quad topology, it makes the loop tools pretty useful, right? Like this is a quad. This is a quad. I think the whole object, if I'm not mistaken, is still quads. Oh, we can, the triangles up here is not, that's like the triangles you get once you subdivide all the quads, right? So this is more of like the render number up there. We could look at it over here. No, this one is not going to show us the name, like all. Is there a way to have it? No. All right, never mind. We'll come back to that. One other thing with the loop cut, right here in the middle of the chair, Control R, there we go. You can, once you press Control R, if you start using the scroll wheel, it starts to make equidistant slices, right, is the default. And so now, for instance, I wanted to create a grate or a grid of some kind. I can click. The second click is still the slide. And so most of the time, if you're going through the trouble of making these equidistant cuts, you don't want to really slide them most of the time artistically. And then you cut. And so now I have way more subdivisions in a single direction, right? When I use the subdivide command, it subdivides things this way and this way. When I use the loop cut command, I can sort of control which direction for the subdivisions. And so now, for instance, I could come back to face mode and Shift Alt click different loops right here. Let's get this one. There we go. Alt click, Shift Alt click, Shift Alt click, Shift Alt click. And now I could extrude all of those at the same time. The corner got messed up there. Or no, it's just sloppy. And let's get the light here. Gee. And yeah, let's say I wanted things to come out of the top here. So Control R. Actually, I want a grid. So Control R, scroll wheel, click, click. There we go. Now I have enough topology to be able to grab something like this. And then manipulate those by themselves there in order to control the topology of the object. If you want to cut a loop and you're not able to find a clean loop around it, the knife tool is for cutting in other instances. And so most of the time, this is going to be useful from point to point, edge to edge. It allows you to just draw your other edge there. Now, if I press Enter, I can do that. And so now I could extrude this by itself. But what about this face is this face here that I'm pointing at, is this a quad? No. Nope. This one here is not a quad. 1, 2, 3, 4, 5. Okay? So this is where this is confusing at the beginning, right? Because it looks like a quad, but this edge has been divided. Even though it is straight, there's now a point in the middle. And so we are no longer quad topology. And so for right now, you know, I'm showing you the knife tool. You should stay away from it at this point, right? The loop cut tool allows you to manipulate the geometry in what is, when you're doing this kind of box modeling, a much more sustainable way. If you just go in and start using the knife tool pretty haphazardly, for instance, if I do this, and I cut from here the whole way over to here, right? And press enter, that actually makes the cut. Now, if I go in and try to alt-click in different directions, you see that the loop select actually doesn't get this stuff here in the middle, because now there's no clean loop going around. The loop select will work in, now it stops here, right? And so by just randomly cutting across the surface of the object, which created a whole bunch of n-gons and tries throughout the entire face, now all of the loop select, loop cut objects, if I go Control R, it's no longer going to cut the entire way around the object. So this kind of box modeling is very additive in that way. Like the decisions, unfortunately, decisions you make early on are going to, change some of the options available to you later on. But if you use this principle to guide you, how much topology do I need? How many cuts do I need to make? Just enough to represent the shape that it is you're out to make at that point.
Can I ask about the tools, like extrude, insert? Does the tool have its own origin? So just like an example, you want to have all the faces of a cube or a building windows all going in, but if you use extrude, they all seem to go, they're all going in one direction or another.
Yeah, that was that extrude along normals, right? So yeah, with the extrude and inset tools, we'll put this in the forest. It'll be it's going to become forest city scene, right? So here we'll come in and yeah, we want to, when you see the inset tool, you're like, oh, I can make windows with that. And so here I'm going to grab this top face here and just sort of move it up. GZ, there we go, kind of like this. And then I'm going to Control R and then create a whole bunch of subdivisions in this way, about there. Click, maybe shift that up a little bit. And then I'm going to come over here and Control R, click, and Control R, scroll wheel, let's say that many windows in that direction. And then on the other side, Control R, scroll wheel, and that many in that direction. There you go. Okay, and so now I want to inset the windows here, extrude them, but in the right direction. And so here, if I grab what I want to use as the window, whatever that is, like maybe this part here, and this part here, and then this part here, I'm just holding down Shift, right? And so if I just press E, it all goes along one axis. If I come in here and use extrude along normals and grab the yellow, now it goes in or out along its individual normals, okay? And so you have to grab the yellow handle and you have to have this tool extrude along normals, as opposed to just E is the top one, extrude region. Once this is here, then the yellow does that, right? If I put this back to here and grab it, you see it's back to doing the other thing. If I put this here, like this, then it does that, right? And so that allows me to do all of the building windows at the same time by doing this and then extruding along normals, inset there.
The fact that you have normal selected as your above your global, local, normal, that doesn't make any difference.
No, not for the tool as it works right then.
Okay.
No. If you're gonna move or rotate or scale, then this would come into play. But here, if I want to extrude this out, make a thing that is going to put a building on top of it, right? And so now, with this, we could start to texture this differently, right? So I want something for the inset windows and something for the other part. So now we get into the thing where, when we start making more complicated objects, you want to be able to save selections here so that you can access them. So for instance, over here, I'm going to go ahead and select the windows. You can come back to the regular select tool. So let's go here. I'm just going to hold down Shift and select these. And we're going to make a vertex group out of this. There we go. I think that's all the ones I did. And so this is in the, what is this, the data tab? Yeah, data tab here. And so now under vertex group, this can be a little wonky. You have to add one, but then you need to make sure that you assign these to that group. And so if we click assign, you can also name the groups, which obviously if you have multiple groups is super useful. So that's Windows assign, yeah. And so now if I come in and I select other stuff like that, right, I've got this, and I want to get back to the windows, you can select Windows and then say select, or deselect everything, then select Windows, and it brings me back and selects the windows, right? Which is super useful, right? Because now with this building here, I could texture these separately, right? And so here now I make a new material that'll be gray or whatever. There we go. And it'll be high metallic and shiny-ish. This will be outside. There we go. And let's look at this here. There we go. And now I want to select the do the windows differently. And so let's come back here and select those. Then come back here and make something new one here called window. And this material I'll make super reflective. And then I'll assign it to those. If I go over here to this view, you should be able to see this a little bit better. There you go. Right, and so now we have those two different materials on the same thing. I am in the material preview because that will allow us to show reflections. Okay, we'll talk about this on Wednesday some more in terms of being able to get some default reflections happening, but this view has default reflections in it, and so that's part of why it's there, so you can sort of see what the heck is happening, because this is the part that's not intuitive. By default, if you're in the other views, there's nothing to reflect. You're building something in a totally reflectionless void. There's no comparable, unless you have some experience building stuff in deep space. Like can't think of a similar real world situation where there would be no reflections, right? If you're in a studio of any kind, there's always stuff and lights, almost all the time. And so those are being reflected. Whereas if you're here in solid view, or even if you're here in rendered view by default, there's no stuff. There's all sorts of ways to address this. We can put stuff here so that we get good looking reflections. But this is something that is also confusing perhaps for new users. It's that, oh, I want glass and metallic shiny stuff. One of the primary visual defining traits of that stuff is not the material, it's the stuff around the material that actually has things to reflect and things like that through there. So there we have a building to use in our let's look over here. If I come back to my stuff, let's come back to here. Okay, so we'll pick up with some reflections, and then also, this is the point light. Let's just have the other light there, because we want to be able to control this a little bit more. But there we go. We've got this happening. Let's save this. Yeah, we want to be able to control our other stuff a little bit more, and we'll get into that next time. Okay, the stuff we covered today, sort of our atomic level learning, and then our next level up manipulation of stuff. Remember, the stuff we did today is not in tomorrow night's assignment, right? This is for next week's stuff, right? Where I was cut off there. So what everyone worked on over the weekend is legit. If you're still working on it and you're doing some more work tomorrow and you want to include some of this, that's fine, but not necessary. Everybody with me there? Okay. And then the lecture search is live. So that's all there. Not only the lecture search tool, but also the lecture timestamp outline tool, which I think is super useful for everybody. Sound good? Okay, awesome. Let's call it there. And Wednesday, just like last Wednesday, we'll look at everybody's stuff that they've got in place, their indoor and outdoor scene. Again, a little bit more fun stuff happening this week than certainly during the first week. And we'll review those, and then we'll keep grinding on this to build up this scene for next week. Sound good? Okay, great. I will see everybody on Wednesday.